Newton's first law explains the behavior of the object when forces acting upon it are completely balanced. Newton's second law of motion explains the behavior of an object when forces acting upon it are not balanced. Newton's second law is about the relationship between force and acceleration. Newton's second law of motion states that the forces acting upon the object are directly proportional to the rate of change of momentum, which is expressed by the formula F is equal to m into a. Here m is the mass of the body and a is the acceleration acting upon it. The factor called mass is a property of matter while other two factors are variables. In this video, we will discuss Newton's second law and its application in our day-to-day life. Bicycle riding can be quoted as an example for this law of motion at work. Your bicycle is the mass. Your leg muscles pushing the pedals of your bicycle is the force. When you push the pedals, your bicycle accelerates. You are increasing the speed of the bicycle by applying force to the pedals. Say you have two identical bicycles. One bicycle has an empty basket in the front, the other bicycle has a basket full of bricks. If you try to ride both the bicycles individually with the exact same force on the pedals, you will be able to accelerate the bike with the empty basket more easily than the bike with the basket full of bricks. The bricks add extra mass to the second bicycle. Hence, you would have to apply more force to the pedals to make the bicycle with the bricks in the basket move. Now let's move to space. In rocket propulsion, the force on the rocket is determined by calculating the rate of change of momentum when the fuel is released. During the initial era of rockets, solid fuels were used as propulsion agents. They increased the overall weight of the rocket, reducing the efficiency of the propellant, which is technically called specific impulse. With the advent of liquid fuels that use cryogenic propellant, rockets were able to generate the same thrust using lesser quantities of fuel. This enabled the rockets to travel more distance in space and discover many things about the universe. Next time when you get into the elevator, just analyze what we are going to see now. When the elevator moves upward or downward, two different forces act on your body. One is due to the acceleration caused by the moving elevator, and the other is due to the acceleration caused by the gravity of Earth. Consider that your body mass is m, acceleration due to gravity is g, and acceleration due to the moving elevator is a. When the elevator is accelerating upward, net forces acting on your body is mg plus ma. Due to this net force, you feel heavier than your actual weight. When the elevator is moving downward, the net forces acting on your body is mg minus ma. So you feel lighter than your actual weight. Now let's enter a cricket stadium. We have seen cricket players lowering their hands while catching a ball. Do you know why? By lowering the hands, players increase the time taken to catch the moving ball. As a result, the rate of change of momentum decreases, and by Newton's second law, the force exerted by the falling ball is reduced. The Indian cricket player MS Dhoni is one of the exceptions who works against this law. He moves his hands towards the ball to reduce the time taken to catch the ball, which makes him the quickest wicketkeeper the cricket has ever seen. Thank you for watching this video. For more such infotainment videos, subscribe to Black Story.